Hey guys, so here is your entrance slip. I know it's labeled as an exit ticket that's here. So the main thing we are looking at here is we are talking about the perimeter. All right, there it is, entrance slip D there. We're talking about the perimeter of circles, which is referred to not as perimeter, because perimeters only for shapes that are made up of line segments. So we get into this word of circumference. So this is Brianna's parents build a swimming pool in the backyard. And Brianna says the distance around the pool is 120 feet. Is she correct? Well, right away we could just flat out tell her no, she's not correct. And the reason why we can say no so quickly is if we've got a 40 over here. So if we kind of see what we're looking at here, that makes this guy a 40 over here. And what ends up happening here is 40, 80, 100 by adding up the three sides. Then she's saying that this curved distance is 20. No way it can be. Straight across it's 20. And that would give me the 120 that's there. So the idea is that a curved, all right, line, all right, can't be the same as a straight line. So that's the idea here, is that this straight line, which is 20, cannot be the same as this curved line. Think about walking. It's not the same distance when it comes down to it. So what they want us to do down here now is to explain how Brianna would determine the distance around the pool. So what we do want to keep in mind here is we know that that's 40, we know that's 20, we know that's 40. So right now we are at 100. So all we need to do is to figure out this curved amount. And what we do want to realize we have there is we are dealing with a half circle. So if I can find the perimeter of the circle, in other words, if I can find the circumference, all we're going to have to do is cut it in half. So your circumference formula is pi times diameter. And the big thing is we use a lot for pi. We can use what we call the exact answer and leave it in terms of pi. We can use 3.14 as the decimal approximation. We can even use a fraction of 22 sevenths. The main thing there is you're going to use whatever they tell you to use. And if they don't tell you what to do, you can use whatever that you want. So what I'm going to do here is I'm going to show you two different things. I'm going to show you the exact answer, all right? And then I'm going to show you the one if we use the 3.14. So the thing about the exact answer is that you just leave pi alone. You kind of treat it like it is a letter. And that's what pi is. It is a Greek letter, all right? And so main thing here is it's just, well, let's show you. I think that's a better way of saying it. So your circumference is going to be pi times, and here your diameter, so all the way across your circle is a 20. So what's 20 times pi? It is 20 pi. It's just like a letter, like we had said. So if you have what's 3 times x, you would say 3x. Um, if you wanted to do 3 plus x, can you add those two together? No, you can't. They're not like terms. You just leave it as 3 plus x. So when I come on over here, find my answer, because I know I have 80, then the distance from here to there is 20 pi. So the exact answer would be 80 plus 20 pi. So again, that's your exact answer because we leave it in terms of pi. Now, if we use the 3.14, we come right back to the formula, pi times diameter. And so then we would say 3.14 times the diameter, which is your 20. We'd reach for our calculator, or we could do some mental math here if you want. And you would get, is it 62 and 8 tenths, right? Because if you multiply it by 2, you'd get 6 and 2800ths, and you multiply by 10, you move that decimal point. Yeah. So you get 62 and 8 tenths. And then when you go back, since we know that that's your distance there, we could add it on to your 80. So in this particular case, you would do your 80 plus your 62 and 8 tenths. And in this particular case, that would end up giving you 142 and 8 tenths. We were in feet, and so it is a distance. So there we go. So if we wanted the answer using 3.14, we get that. If you wanted your answer using the as in the exact answer, you would get that. So that's something that you really want to watch for today. So definitely check your answer key as you go. I would kind of check it problem by problem that we're looking at there. And then the last one, now explain the relationship between the circumference of the semicircle part of the pool and the width of the pool. Explain the relationship between the circumference of the semicircular pool and the width of the pool. Be honest here, people, I have always skipped this question here because it's so open-ended that's there. So let's not even worry about that right now because that is pretty vague and we could take that in a whole lot of different directions of when it comes down to it. So, all right, people, you're there. Do that classwork, check your classwork, email me with any questions you might have.